Okay, here we are asked to write this Riemann sum as a definite integral. So what we want to do is to rewrite this and hopefully into a definite integral from a to b fx dx. Okay, so we need to figure out what is the function and what are the lower bound and the upper bound. Okay. Now, remember we said the limit of a Riemann sum k from 1 to n f of a plus k delta x and times delta x. This equals um, a definite integral, right? If the function fx is integrable, if it's continuous. So we wanna compare. Now to solve this problem, we wanna compare these two summations. So we wanna match this this formula with what we are given here and figure out what is the function and what is a and what is b. Okay. So in the Riemann sum, each term has two components. The first component is a function, and the second component is this delta x. Okay, and we said that the function stands for the height of a rectangle, and the delta stands for the base, stands for the width of the rectangle. Okay, so if we compare this with what we're given in this Riemann sum, it also has two components. I mean, each piece also has two components. The first component is this function sine of phi plus 3k over m, and the second piece is 3 over m. Therefore, we know that this function is equal to sine of phi plus 3k over n. So so the function f of x, we know it's a sine of x. Okay, and then since f of a plus k times delta x is equal to sine of phi plus 3k over m, that means this piece is equal to this piece. So a plus k delta x is phi plus now 3k over n. Let me rewrite this into k times 3 over m. Okay, if we compare these two things, we can see that if this is phi, then the delta x would be 3 over m. So we figure out, okay, a equals phi, and delta x is 3 over m. Okay, so then if we go back to this definite integral, now we know that a is phi, and we know that function fx is sine of x dx. So the only thing we don't know is b. So how to find b? To find b, we're gonna use delta x, because the formula for for finding delta x is delta x equals the difference between a and b and divided by n. So right now, since a equals 5, so we wonder which number minus 5 over n will be 3 over n. In other words, we want to think about which number minus 5 equals 3. So the answer is 8. Therefore, b equals 8. B equals 8. So when we write this Riemann sum as a definite integral, the answer will be the integral from 5 to 8 sine of x dx. Okay. All right. Sometimes we can use the geometric formulas to calculate the definite integral. If the bounded region has a shape which we can use which can be which the area can be calculated by using those geometric formulas. So here I will show you some examples like that. Let's look at the first problem. We want to evaluate this definite integral from 1 to 3 x plus 1 dx. So here the function fx is x plus 1 and a equals 1 and b equals 3. So if we graph this function, it will be a straight line, right? It will be a straight line. Say when x equals 1, the function value is 2. When x equals 2, the function value is 3. When x equals 3, the function value is 4. Right? So it's a straight line. Okay. So by connecting these points, you will have a straight line. Okay. Now next, we need to draw the bounded region. Okay. So the region is bounded by the graph of this straight line and by the x-axis and by the 2 points x equals 1 and x equals 3. So x equals 1 is the graph is this vertical line. Okay. And x equals 3, the graph is this vertical line. Okay. So here the bounded region is this one. And if we are put this down, like if we shift this region in this way, you can see this is a trapezoid. Right, this region is a trapezoid, and we know the area. The formula for finding the area of a trapezoid is let's say this is a height, and I call this base as as a u, and this as a v. So the area of a trapezoid is 1/2 times the height h times the sum of the lower base plus the upper base. Right. So in our case, what is our height? The height is this. Okay, this is our height, and the length of this is the lower base, is u, and the length of this is the upper base, v. Okay, so how to find the height? The height is the distance between these 2 points, which is 2, right? 3 minus 1. And the upper base is the function value of 1. So that equals 2. Right. And then the lower base is the function value of 3, and that is equals 4, right? Equals 4. So the area of this bounded region equals 1/2 times 2 times 2 plus 4, which equals 6. So the answer to this definite integral is 6. Right. Okay, let's look at another one. Here we want to evaluate the integral from -3 to +3 square root of 9 minus x squared. In this case, the function fx is the square root of 9 minus x squared, and a equals -3 and b equals 3. So if we graph this function, the graph will be a semicircle like this. So the region bounded between this graph and the x-axis, and bounded by these 2 points, x equals -3 and x equals +3, will be this semicircle. And since the area of a semicircle is 1/2 times pi r squared, so to find the area of this bounded region, we just need to know what is the radius. So the radius equals 3. The radius is 3. Therefore, the area is 1/2 times pi times 3 squared, which is 9/2 pi. So this integral equals 9/2 pi. Okay, let's see the next one. We have the integral from 0 to 8, x minus 4 dx. Function is x minus 4, fx equals x minus 4, a equals 0, b equals 8. So once we graph the function from 0 to 8, the graph will be like this. Okay, and this time the the region bounded by the graph and the x-axis. Let me draw that. So this is our x-axis, and x equals 0 is this, and x equals 8 is this. So in this case, we have some area, we have some region below the x-axis, and since the definite integral gave us the net area, so in this problem we need to find what is the area of this piece, the area below the x-axis, and then find the area above the x-axis, and then find their difference. The region below the x-axis is a right triangle. Okay, so it's a right, since it's a right triangle, so to find its area, we just need to know what is a base and what is a height. Okay, the height of this triangle is 4, right? From 0 to -4. So the length equals 4. Now the base is the length of this piece. And we can know this. Why we can know this? Because when x equals 4, the function value equals 0. So at this point, this is the x-intercept, and the coordinate of this point equals 4. So the base of this right triangle is 4. So the area of this right triangle is 1/2 times h times the base, which equals 1/2 times 4 times 4. So that is 8. Okay. Okay. And then let's see what is the area above the x-axis. It is also a right triangle, and the base is also 4, from 8 to 4. So the base is also 4, and the height is the length of this, is the function value at 8. Now the function value at 8 is 4, 8 minus 4. The height is also 4. So the area of the second right triangle is also 8. Then the net area is the difference of these two. So it is 0. Okay, this is the base. And this is its height. Okay. So if the region has if the area of the region can be found by using a geometric formula, then we can use that formula to evaluate a definite integral. So in that case, we don't have to use a Riemann sum. Okay, and when we do that, make sure if they are if there are some areas below the x-axis, then we have to consider using the method for finding the net area.